Welcome to another exciting AMC 12 solution walkthrough. In this video, we'll tackle problem 18 from the 2024 AMC 12A, a fascinating geometry challenge that's sure to test your problem-solving skills. Let's dive in. Ready to take your problem-solving skills to the next level? Message me on WhatsApp now. Details are in the description. On top of a rectangular card with sides of length 1 and 2 plus the square root of 3, an identical card is placed so that two of their diagonals line up as shown in the diagram, with AC being the aligned diagonal. Continue the process, adding a third card to the second, and so on, lining up successive diagonals after rotating clockwise. In total, how many cards must be used until a vertex of a new card lands exactly on the vertex labeled B in the figure? The options are A6, B8, C10, D12, and E, no new vertex will land on B. To solve this, let's carefully analyze the geometry of the problem and derive the necessary angles. We'll start by calculating the tangent of half the rotation angle, then proceed to find the full rotation angle step by step. Let's begin. A reaches B by rotating 360 minus alpha degrees clockwise. Therefore, the minimum number of steps required for A to reach B is at least 360 minus alpha, divided by alpha. Simplifying this expression gives us 360 divided by alpha minus 1. Next, for B to reach itself, the total rotation required is 360 degrees. This means the number of steps is simply 360 divided by alpha. For C to reach B, the rotation required is 180 degrees. Thus, the number of steps is 180 divided by alpha. Finally, for D to reach B, the rotation needed is 180 minus alpha degrees. Therefore, the minimum number of steps is 180 minus alpha divided by alpha, which simplifies to 180 divided by alpha minus 1. First, we find the tangent of half the rotation angle. Using the relationship between the midpoints and diagonal lengths, we calculate tan of alpha over 2 equals mb divided by OM, which equals 1/2 divided by the quantity, 2 plus the square root of 3 all over 2. Simplifying, this becomes 1 over 2 plus the square root of 3 multiplied by 2 minus the square root of 3 divided by 2 minus the square root of 3. This equals 2 minus the square root of 3. Next, we use the tangent addition formula. Tangent of alpha plus beta equals the tangent of alpha plus the tangent of beta, divided by 1 minus the product of tangent alpha and tangent beta. For the full rotation angle, we calculate tan of alpha equals tan of alpha over 2 plus alpha over 2, which equals 2 times tan of alpha over 2, divided by 1 minus tan squared of alpha over 2. Substituting the value of tan of alpha over 2, we get tan of alpha equals 2 times the quantity, 2 minus the square root of 3, divided by 1 minus the square of 2 minus the square root of 3. Simplifying, this becomes 2 times the quantity, 2 minus the square root of 3, divided by 1 minus the quantity 4 plus 3 minus 4 times the square root of 3. We then simplify further. Tan of alpha equals 2 times the quantity, 2 minus the square root of 3, divided by negative 6 plus 4 times the square root of 3. This simplifies to the fraction 2 minus the square root of 3, over 2 times the square root of 3 minus 3, multiplied by 2 times the square root of 3 plus 3, divided by 2 times the square root of 3 plus 3. Finally, simplifying again, we recognize the angle. Tan of alpha equals the quantity 4 times the square root of 3, plus 6 minus 3 times the square root of 3, all over 12 minus 9. This simplifies to the square root of 3 over 3, which equals tan of 30 degrees. Thus, the rotation angle alpha is 30 degrees. Now that we've determined the rotation angle, we can calculate the total number of rotations needed to return a vertex to B. If we plug in 30 degrees for alpha and check all the cases, we find that the minimum is for D. After 5 rotations, D reaches B, so the minimum number of cards is 6. Thanks for tuning in. I hope this solution was helpful. Keep exploring, keep questioning, and I'll see you next time.